Hi everyone. In today's lecture, I will discuss two very important topics used widely in modern electronic systems. The first one is switch mode power supply. The second one is switched capacitor filter. Both these topics are extremely important from practical application and also in the exam point of view, especially in integrated circuit design and power electronics. First, we'll see the introduction to SMPS. Let us start with switch mode power supply, a commonly called SMPS. And SMPS is a power supply that converts electrical power efficiently by operating the switching device at high frequency instead of working in the linear region. Unlike linear power supplies where excess voltage is dissipated as heat, SMPS works by turning the switch on and off rapidly, transferring energy in small packets, regulating the output with very little power loss. That's why SMPS units are smaller in size, lighter in weight, and much more efficient than linear mode power supplies. You will find SMPS almost everywhere today, from the mobile chargers to the industrial machines. Next, we are going to discuss about the linear versus SMPS power supply. First, let us compare both briefly. In a linear mode power supply, efficiency is low, large heat sinks are required, size is bulky. In SMPS, the efficiency is around 70 to 90%. Heat dissipation is minimal. High frequency operation allows small transformers. This is the main reason the linear supplies are slowly being replaced by SMPS. Next, we will discuss the SMPS block diagram. The SMPS block diagram is comprises of many stages. The first one is the input rectifier and filter, which is used to convert the AC input into the DC using a rectifier. The filter removes ripples as well as noises. The next one is switching and driver circuit. This is the heart of the SMPS. The power transistor such as a MOSFET, which is switched on and off at high frequency, followed by the transformer or inductors. Energy is transferred through a high frequency transformer or inductor. In isolated SMPS, this provides electrical isolation for safety. The next one is the output rectifier and filters. The high frequency AC is converted back to DC and filtering gives a smoothing output voltage. The next one is the feedback and regulation mechanism. The output voltage is sensed and feed back to the control to the duty cycle, ensuring constant output even if the input or load changes. The next comes SMPS topologies. Depending upon the application and power level, different topologies are used. Non-isolated topologies. If you can take the non-isolated topologies, which are simpler and used in especially DC to DC applications. The different types of non-isolated topologies are buck converter, which is mainly used for step downing voltage. Then boost converter, which is used for step up voltage. Buck boost converter can step down as well as step up. Then that comes isolated topologies. In isolated topologies, we have different types of topologies, that is flyback converters, forward, push pull, half bridge converters, full bridge converters. These are used when isolated and high powers are required. So the selection of the topologies depends upon various factors like output voltage and current, power rating, isolation requirement, efficiency. Next, we are going to discuss on the working principle of SMPS. The SMPS works on the principle of switching regulation. The switch operates at higher frequency, typically 20 kHz to 500 kHz. The output voltage is controlled using a pulse width modulation technique. By adjusting the on time of the switch, the output voltage is regulated. During the switch on, the energy is stored in the inductor or transformer. During the switch off, the stored energy is released to the output. A feedback loop continuously monitors the output to maintain the stability. The efficiency considerations. The minimal loss in the switch and transformer makes the output is more efficient and optimal component ratings. The next one, applications and summary of the switched mode power supply. The SMPS is used in desktop computers, mobile phone chargers, LED drivers, industrial programmable logic controllers, simply we call this industrial PLCs, security systems. To summarize about SMPS, which provides high efficiency, compact size and reliable power conversion, makes it ideal for modern electronics systems. We move on to the next topic, that is our second topic, switched capacitor filters. A switched capacitor filter is an analog filter where the resistors are replaced by capacitors and switches. These switches are controlled using a clock signal, making the circuit suitable for integrated circuit implementation, simply for IC implementation. The switched capacitor filters are widely used because we have accurate resistors are difficult to fabricate on integrated circuits, whereas the capacitors are much more precise when compared to the resistors. So the working principle. The core principle is the charge transfer of a capacitor controlled by the switches. The basic idea is the charge transfer. A capacitor is charged during one clock phase. It transfers the charge during the next phase. This repeated charge transfers creates a current. The effective resistance is given by R equivalent equal to 1 divided by C into clock frequency. So instead of changing the resistance value, we can change the clock frequency to control the filter behavior. Non-overlapping clock signals ensures no charge loss. The next one is building blocks of an switched capacitor filters. The switched capacitor filters mainly consists of the precision capacitor, MOS switches, operational amplifiers and non-overlapping clock generators. The switched capacitors usually polysilicon or metal insulator metal for high precisions. The MOS switches, which replaces the resistors, which controlled to sample and transfers the charge. So the operational amplifiers, it serves as an integrators or summing amplifiers in the switched capacitor structures. Non-overlapping clocks ensures proper phase operation and prevent shorting or loss of charge. Next, the types of SC filters. We have the SC filters can be used in different areas, like low pass SC filters, which integrates the sampled inputs and accumulates to the output capacitor. The high pass filters interchanges the input capacitor with integrating capacitors to plug DC. Then state variable filters, which producing low pass, high pass and band pass outputs, which is obtained by replacing the resistance in classical circuits with switched capacitance equivalents. The cutoff frequency depends not only on the capacitor ratio and clock frequency, making the switched capacitors filters highly accurate and tunable. Next, the advantages, disadvantages and applications of switched capacitors filters. The main advantages, it requires small silicon area compared to the large integrated circuits. The next one is high precision in cutoff as well as the center frequency due to well controlled capacitor ratios, and it is easily integrated into integration in ICs, so we can easily design any value of capacitors, and also it consumes very less power. The main disadvantages are switching noise. That is, the switching introduces noise and aliasing. The aliasing is the overlapping of the two signals, which can be avoided by using anti-aliasing filters. And it is limited to high frequency operations because the reactance is inversely proportional to frequency, so we cannot make use it for high frequency applications. Next, requires a stable and accurate clock pulse. The main applications of switched capacitors filters, as it is mainly used in analog to digital converters, audio signal processing, anti-aliasing filters, mixed signal ICs. To conclude this lecture, the SMPS is essentially for efficient power conversion, and the switched capacitor filters are ideal for precise filtering in integrated circuits. Both the topics are extremely important for VLSI and analog design engineers. Hope you enjoyed this lecture. We'll meet again with the next lectures. Thank you for your patience.